Greetings, I am Steel Legend Aki, protector of the digital frontier, and I have come to defend you from forces of lagging and buffering. Let me share with you what my body is made of. The ASRock B850M Steel Legend Wi-Fi.
Yep, that's right. You've heard what you've said. Going to share with you guys on this motherboard, but before I begin, I'd like to thank ASRock that provided this cute mascot known as the Steel Legend Aki and the motherboard for me to share with everyone. Now, first thing when you unbox, these are the stuff that you will get. First off, you'll be provided with a set of SATA cables, one which is straight, the other which is right angle. A set of Wi-Fi antenna, Velcro stripes which has the ASRock logo for you to do cable management, additional M.2 screws, and this is the M.2 standoff, a sensor probe, installation guide, and the regulatory notice, and of course the gorgeous Steel Legend motherboard. I wouldn't have a clue what you guys think about this board, but for me, the look is extremely aesthetically pleasing based on the fact that it has dual tone, which I like, a touch of black and white, or should I say not really white. As you can see closer, right, there are a patch of white, cream with a subtle grey labeling, inclusive the back, a very nice Steel Legend logo, and with subtle design at the background that projects out futuristic, and with a touch of linings over here, inclusive on the M.2 heatsink, which says blazing M.2. And cute thing is that they have included this detailed design, attention to detail, with fake votes which blend in to the design. At the lower section over here, right, though there are no design, but there are ARGB effect only underneath the chipset heatsink. Nice touch. Now, this is a 6-layer PCB m-ATX form factor motherboard, and there are 2 ounces of copper traces throughout the whole board, and the measurements is 244 by 244 millimeter. The thickness of the rear VRM heatsink, this is at 40 millimeter. As for the power phase of this board, it's at 12 plus 2 plus 1, having 60 choke. And do take note that only the 12 VRM is with a heatsink, else for the 2 plus 1 there isn't, but I believe that will be sufficient enough. Right at the center where you have the 1718 socket, this is catering for 9000, 8000 and 7000 AMD processor. At the bottom, you have a total of 4 DIMM slot, and it's only meant for DDR5, having a max capacity of 256 gig, running on dual channel, and having both profile of XMP and Expo at a max overclocking speed of 8000 MHz. Now, do take note, I have mentioned that you can populate all the 4 DIMM slot to have a max capacity of 256, but don't assume that you buy, full 256, right, with a overclock profile of 8000 it can run. So do take note on this. This board also comes with 2 PCIe slots, as you can see over here. The top slot is controlled by the processor, and this is of Gen 5, having a full 16 lane and a full speed of X16, and it's not lane shared. As for the bottom, this is controlled by the chipset, and this is Gen 4, running at a speed of X4, and again no lane sharing. As for the M.2, there are a total of 3 M.2, where you have 1, 2 and 3. The first 2 M.2 is controlled by the processor. The top slot is Gen 5, running on speed of X4, backward compatible, and this is Gen 4, running on speed X4, and again backward compatible. The only thing is this M.2, which is controlled by the chipset. This is Gen 4, running at a speed of X2. And all that I mentioned, right, there are no lane sharing. Well done. The locking and releasing mechanism of all the M.2s inclusive of your GPU is pretty straightforward. Starting off with the GPU. As you can see, this PCIe slot is reinforced with a metal plate. This is good to form rigidity, and to plug it in, you just plug it in, and this is in lock position. And take note on this latch where it has an extension lever where you can just press it with ease. So when you want to remove off your GPU, right, you just need to press this, and if you have not noticed, right, inside there is this tongue sticking out. Okay, let me just zoom in and show you. See? So when this is pushing your graphic card up, your graphic card will be in place as in like release position, because this latch here, right, is spring loaded. So when you press, as I mentioned, your graphic card is already out, it will stay there, so leaving you having both hands, right, to hold on your graphic card and to remove it. Good mechanism. Now as for the M.2, you will need to use screwdriver to unscrew all the okay, probably I'll zoom out. You will need to, as mentioned, use a screwdriver to unscrew the heatsink for the top and the last slot, which I already done. Now for the top slot, the screws are captive, so you don't have to worry that it's gonna go missing, and it's pretty beefy for this top slot. This is why you can put a Gen 5 M.2. And with this say, right, for thermal solution, there is a thermal pad at the bottom and a thermal pad at the top. If you're using double-sided M.2, just like this, okay, double-sided, make use of the two thermal pad at the bottom and at the top. If you're using single-sided, just make use of the top. Okay, and do take note when you're mounting the top M.2, because when you mount it, right, there are no locking mechanism at the back. So I do advise you how you place it back is align this screw to the front first, anchor it properly, okay, then tighten slightly just to anchor the point. See, this is anchored. Then on the M.2, right, just press it down, followed by this, eyeball it. Then once it's done, right, you can screw your thing in. So this is how it works. Now as for the bottom section where one doesn't have a armor shield and this you have the armor shield, this armor shield again with two screws, you can take it out, but do note that the screws are not captive, see, so don't lose these screws. Alright, and the way to lock, be it the second slot or the last slot, all is needed is just to plug this in, okay, with this swivel point at the back, press this down and to lock, and to release, just do this. See, quite easy. Now come to a tip. As you know that this is without a heatsink, so you might want to purchase a M.2 that comes with a heatsink. And you might worry, since this is the PCIe slot for your GPU, right, what if your heatsink is too thick? See, like this, there might be obstacle for you to plug in a 3-slot card, okay, based on the fact it's too thick. So what do? Well, I have a solution for you. If you notice, right, at the bottom slot where you place the armor shield, this is flat. And how do I transfer this to here? Quite simple. Take a look at here. There is this bolt over here, and there's a screw hole over here. Same goes to here. So what you need to do, right, your case should have this kind of standoff bolt where one side you mount the hexagonal shape and the other side is actually a screwdriver Philip pattern. Unscrew this. Alright, just going to show you. See, I'm taking off the standoff. Place it over here. So when you've done this, right, make sure you tighten it. Okay, assume it's tightened. Right now, you can place your M.2 and instead of making use of this heatsink right at the bottom right now you can put it at the top. See? And this is flat. This will not cause any problem when you slot your graphic card. And at the bottom slot right, you can make use of this kind of heatsink that includes with your M.2, which is of a thicker mass. Not a problem. Right, so that's the solution. So just in case that if you purchase M.2 that is of this thick, right, and you've been trying to mount this, you can't, due to the fact that it obstructs your GPU from plugging in, then you can do this method, which is a trick, right? And you might worry that, oh, cool, this heatsink is directly underneath the GPU. Not to worry, as you can only populate a Gen 4 M.2, and this is sufficient, or should I say this bracket over here, or this heatsink over here, is more than sufficient to cool down your Gen 4 M.2. The onboard audio equipped in this board is making use of the Realtek ALC 1220 codec, and it supports 7.1 channel surround sound and is of high definition. As for the connectivity, starting off from here, this is a 4-pin PWM fan connector, whereby it labels at CPU_fan 2. And over at this end, this is the TPM module, followed by this is meant for your front IO headphone microphone jack. You'll be provided with two 3-pin 5V ARGB header, and this header are in gray. Also at the top, yes, this is also 3-pin, but it's not meant for ARGB devices. It's meant for advanced user using an external device to be connected over here to do your advanced configuration and advanced troubleshooting. Okay, we do not use this at all. So at all times when you're connecting to any ARGB devices, make sure you use the gray headers over here and not the top. You'll be provided with total 3 4-pin PWM fan headers, which labeled as chassis fan 1, chassis fan 2, and chassis fan 3. 2 USB 2.0 header, a sensor pin, whereby this board does come with a sensor cable. One end connected to this 2-pin, the other end, which is the probe, you can put anywhere of the component that you want to detect the temperature. And the temperature reading will be reflected on hardware info 64 or IDA 64. Next, you have a 3.0 socket, which is meant for your front Type A USB port, total of 2. Next, you have the clear CMOS button. This area over here, let me just zoom in. Now, let me split this way. These are meant for legacy cases, whereby at the top 4-pin, right, these are meant for internal speaker. At the bottom, where you have 3-pin, these are meant for the power switch that comes with a LED. Next, you have the front I/O connectors for your power switch, your reset switch, your power LED, and your hard disk LED. Okay, let me just zoom out. As for the front, there are a total of 4 SATA ports, 2 right angle and 2 straight. Now, if you were to populate any additional storage device on this SATA port, there won't be any lane sharing. So total of the SATA port and the M.2 slot, you can house up to 7 storage devices. Right at the top, this is another 3.0 socket, which is meant for your front USB Type A port. So total, you can plug 4 USB Type A port at the front. Now, provided that your case do have 2 3.0 plug. Alright. Next, you have a Type C socket, which is meant for your front I/O Type C port, and this has a transfer rate of 5 gig. Next, you have a 24-pin socket, which you draw power from your PSU connected to here to supply power to the rest of your motherboard. And you have a legacy 12V RGB connector. Now, this in white, please do not connect any ARGB devices to here, right? I mean, you can't plug in anyway, but I'm just warning you, Next, you have a 3-pin 5V ARGB connector. Now, I've forgotten one thing. Moving back, there are debug LED over here. So, when you boot out the system, right, if you are not able to project or maybe having some RAM issues or the CPU issues, right, this will light up, telling you that which are the issues that you have to rectify, right? Now, to the last section right now. At the top, you're provided with a 4-pin PWM fan header, which labeled as CPU_fan1. Next, you have the EPS cable. One is 4-pin, one is 8-pin. Now, at all times, you can just plug on the 8-pin, and it's sufficient to power up your processor or to draw the vCore from the VRM. Not an issue. If you want to plug the 4-pin, by all means, you can go ahead, but I don't think it's necessary unless you want to do extreme overclocking, whereby you want stability and such. But it's no harm plugging in together with the 8-pin, just for aesthetic look. But for my advice, right, one is more than enough, which is plug on the 8-pin. As I noticed, there's a limitation on the fan headers. There are a total of 5, as you can see here, the 5 points. 3 at the bottom, 1 at the rear, and 1 at the top. And all these fan headers are of 3 ampere, except for the CPU fan 1, which is 1 ampere. Now, if you are placing an air cooler, I would advise you to do this. This is your case. For example, you have the top fan, you have the front fans, you have the bottom fans, and then you have the rear fan. For your air cooler, right, when you plug into your case, right, I would advise you to plug your air cooler fans to CPU_fan2, which is at the rear. Now, I know you might be saying, hey Kyo, I want to place my rear fan over here so that it's easy access. But imagine that your air cooler is plugged over here, right? If you are going to free up this space for your rear fan, right, you got to route your air cooler cable to the bottom, which you will want to avoid. So best arrangement, as I see it, right, for air cooler fans, plug it to the rear. Then as for the top fans, plug it to CPU_fan1. For the front fan, plug it to chassis fan 3, which is here. For the rear fan, you got to route from the rear all the way down to this, which is the chassis fan 1. See, I'm pointing the rear fan to the chassis fan 1. And as for the bottom fans, plug it to the chassis fan 2. So with this arrangement, right, all is being populated nicely. So you don't have to worry about too long or too short of your fan cables. Now, for liquid AIO, a different play, whereby the liquid AIO have the radiator fans and your pump connector. I would advise, based on this fans, this case structure, plug your radiator fans to CPU_fan1 and your pump to your CPU_fan2. As I mentioned, all these headers are 3 ampere except for the CPU fan 1, which is 1 ampere. So you want to have your pump to run consistently with a amperage, sufficient amperage. So I would advise you to plug to your CPU fan_2. And once this is plugged in, right, have your radiator at the top. Okay. Then next, for the front fan, as usual, chassis fan 1, which is this connector over here. Else for the rear, again, you got to route all the way to the bottom, which is this. See, I pointed the rear to the chassis fan 1, which is this connector over here. Else for the chassis fan 2, which is for your bottom, connect this to this. Right, that will fully cover all the fans that you want to populate in such case scenario. This is the rear, where you have the DP port version 1.4 and the HDMI port version 2.1. And both this port has the capability of projecting 4K 120Hz. And both ports are making use of the integrated graphic on your processor. Next, you have the BIOS flashback button. Yes, you're able to update your motherboard BIOS using this function. And the port for the firmware is this, which you can see a fainted rectangular line. So make sure you download the latest BIOS on a thumb drive and it's FAT32 version 2 plugged to this port and to make use of the BIOS flashback. There are a total of 7 USB Type A port, whereby you have 4 in black, which is version 2.0. The one in yellow, this are version 3.2 generation 1, and it has a transfer rate of 5 gig. Now, why is it called Lightning Gaming? It is much advisable that if you do not want intermittence on your mouse or keyboard, plug those devices on this yellow port. And for the light blue, this is generation 2, having a transfer rate of 10 gig. Right at the bottom, a Type-C port, which is generation 2 and having a transfer rate of 10 gig. Right above, this is the RJ45 socket, whereby it has a transfer rate of 2.5 gig. The Wi-Fi 7 socket, and it does support Bluetooth. Right over here, this is the audio section, where you have the line in, the line out, which is meant for your speaker, and the microphone in. Here comes the fun part, whereby I test the network adapters, be it the Wi-Fi or the wired. As you can see right now, it's both disabled, so I'm just going to enable my Wi-Fi and going to test the upload and the download locally. Okay, this is local Singapore. Okay, StarHub Limited, and let's see how the bandwidth goes. See, good ping, very strong signal, which is 1.8 gig, downloading from this Wi-Fi adapter. By the way, this is using a MediaTek 160 channel bandwidth Wi-Fi adapter. And see, it's consistent on the download and the upload. Okay, let me just try again. See if it's consistent. Good ping time again, and look, it's very consistent on the download. Gonna confirm if it's good on the upload. Again, it's very consistent. I have no issues with this network card, which some of you have actually claimed that MediaTek is horrible. Okay, let me go to another, okay, probably Maxi, Kuala Lumpur, 195, hang on, 195 miles. This is Malaysia. Oops. Here we go. 13 milliseconds ping, not that bad. Okay, very consistent, about 1.6 gig. And let's see what's the upload. Yep, in fact it's even better, 1.8 gig. So it's pretty consistent on this Wi-Fi adapter. I'm just going to change another location. I would say, let's see, this one. How come it doesn't change? Okay, let's see how this fares. See, it's strong too. So there you have it. The Wi-Fi adapter does check out the 160 bandwidth channel, which is coming from MediaTek. See, it's very consistent. Now I'm just going to enable this and disable the Wi-Fi. Now for wired connection, right, it's gonna be strong, that's for sure. And this motherboard do provide 2.5 gig transfer rate. So right now I'm just gonna head back to Singapore and just to try. Oh, even better, the ping rate is only 1. See, hovering around this area, this data fetching rate is good, which is quite near 2.5 gig. See, consistent, I have no problem. And you're gonna test something else, local, fantastic. So let's try something. Probably I would say this. I wouldn't know if this has the capability to transfer such high rate. Let's see. And sometimes it doesn't. Okay, this is actually a 1 gig server. That's why I'm receiving this download speed, and the upload will be the same. That's why I'm saying that it doesn't. It does matter if the server do provide the bandwidth or not. Because even if you have a Wi-Fi 7 card or a very strong Ethernet card, right, it doesn't mean that it will fetch. It still depends on where you are fetching the data. So for example, let's say I take this. Good ping. See, this server does provide those kind of data signal or bandwidth. That's why I'm able to fetch. Else your weakness earlier, right, it does not fetch up to 2.3 gig, but this does. So proven that both card, the wired or the Wi-Fi, it does check out well. Now I'm just going to share with you with the RAM training cycle timing. If you are moving from Intel platform to AM5 platform, or migrating from AM4 to AM5 platform, this is as expected. When you set up everything together and when you boot to UEFI, it will take a very long time. Okay, but this is only for the very first time. Subsequently, when you have verified the RAMs, when you reboot the system, it will be very fast. Same goes to when you're in Windows or even doing a cold start. Now on my top right, you will see a black screen. This is connected to my motherboard. So when you boot to UEFI, right, it will show on the black screen. And there is a stopwatch over here. Now, to show you how long it takes, I will press this power button together with the stopwatch. Here we go. Now at this period of time, when the debug LED is lit up, right, just let it be. It will stay there for a while. Do not reset the system. Do not power down and to clear CMOS and keep on doing it. You will hurt the board itself. And also take note that the bigger capacity of RAMs that you have, right, the longer it will be. But this is only for the very first time. Right now I'm using a 32 gig kit. So probably I would say around 1 minute or so. If you are using 64 or 96, right, that will be even longer. Probably I would say 2 to 3 minutes. Now as you can see, my timer right now is at the 39-second mark. And once it's booted up, right, I'll just stop it. Probably I would say it would take about 1 minute. See, it takes about 46 seconds. So as mentioned, this is the very first time your RAMs have been verified. And subsequently, when you use it, right, when you reboot, you'll be much faster. Take for example, right now, I'm just going to shut it down. Since it's already verified, I'm just going to do a cold boot. Okay, my system is hot. As you can see, there are no ARGB on my motherboard, so it's totally off. Right now, I'm just going to do it again. Let me reset my timer, or should I say stopwatch. Here we go. So as mentioned to you, after your RAMs are verified, right, the second moment, or should I say the reboot or the restart, or even press startup, it will be fast. See, it takes about 14 seconds. It's so much faster. So this is the reaction or behavior of how AM5 platform is. Now the question is, how well will this board perform if we are to plug in a high-end processor? But before I talk about the specs, take note on the ARGB effect on the motherboard. The only area that has ARGB effects on the board is on the chipset. As mentioned, it's underneath the chipset heatsink. Now back to the spec. I will be using a AMD Ryzen 9 9950X processor, and to cool this processor by using this Arctic liquid freezer 2360. And how it goes is, it sucks in the air from the back and through the radiator to cool the CPU. And some of this air, right, going through the radiator will sweep some of the warm air within the motherboard area. I'm using a 32 gig kit from King Bang, and do note, I'm doing this performance test at a room temperature of 30 to 31 degrees Celsius, and I wouldn't want to turn on the aircon just to show you, as the atmosphere here in Singapore is very different from cooler country, whereby if you're in a cooler region, right, surrounding the board itself, right, will be cool air. Else here in Singapore, right, the surrounding is warm air. So this will let you judge if you are in a hot and humid country, right, how this board will perform for you. And to explain to you how I configure it, it's pretty straightforward. There are two tests that will be conducted. One is the default and the other which is my own PBO setting. And do take note that the M.2, which is the OS drive, I'm making use of the default motherboard heatsink. I just want to see how well the heatsink perform. Now as for the configuration for default, right, all I've done is only on OC Twinkle and to set on the DRAM profile, setting this to Expo, and I'll just save it and to run. This is by default, so that will be a benchmark for that. Then right after that, right, I'll do my own configuration, and what I've done on my configuration is pretty straightforward. Besides setting the RAM profile, I will do the offset on my vCore, and I'll set this all the way to -100, which I know it will run. And also to set the SoC Unicore OC voltage, you do not require 1.2. Now default I'm running at 1.2, okay? That is one of the first benchmark, but the second I will just tweak this. And also kindly note that when I'm doing all these settings, right, do not assume that you follow all my settings, right, it will work on your processor, as this is based on what the silicon chip is on this processor. That's why I can do all this. I've done numerous of setup and timing for this. Next I will do the PBO2, which is the AMD overclocking precision boost overdrive. I'll set this to advanced and having the limits manual, and I'll set this to 230 watt. Okay, why am I adding 3 more zeros? Based on the fact that it's milliwatt. Okay, and as for this, I will set it to 215 ampere, and the other is 215 ampere, having it equal. Next, I will not touch this, neither will I touch the CPU boost clock override. I know many of you will do this, but I find that it's very inconsistent, as it's like it fluctuates up and down, up and down. I don't like that. I like stability. Instead, I will touch on the curve optimizer. Now, for curve optimizer, this time, this board is able to do much more. So I will set it to per CCD. And I know the first 8 core are pretty strong. I'll set it to -20. And the next, the last 8 core, right, I'll set it to 15, giving it more slack. Then come to the curve shaper. Now, if you want to know more information about the curve shaper, how you set it and such, right, I will leave the description, or should I say the content in my description, which is coming from Skater Bencher. Thank you very much for the good documentation on curve optimizer, so we can follow that. Now, having said this, right, I will set this to, let's see, yep, that's correct. Okay, I will not go into details on what I'm doing right now. In fact, these are my settings for it. Okay, probably I'll just explain to you guys what this is. Now, for curve shaper, right, it's a more advanced usage to tune your processor, whereby you can set additional 3 more points based on the temperature. As you can see here, right, see, okay, let me just put auto first so that you can see. As you can see, there are 3 points for minimum, which is low temperature, mid temperature, and high temperature. Low, again 3 points, mid 3 points, high 3 points, and max 3 points. So basically, the first 2 points, right, which is the mid frequency and the low frequency, that is untouched. So it's like, even if you set it right, it doesn't do much impact. The impact will start where it goes to the mid frequency. So this is where I will do my configuration. So having a negative magnitude of -20 for the low temperature, and the mid temperature I'll set it to -15, and for the, let's see, did I set it right? Okay, enable. Yep, okay. Then for the mid frequency high temperature, right, I'll set it to -10. Okay, same goes to the rest, as this is actually my setting in general. Okay, So again, these are my settings. Do not assume that if you to apply this on your 9950X on this motherboard, right, it will work. You got to tweak. Sometimes you can't even do this much. Probably you can only do 5, okay, at the high temperature magnitude. So take note on this. It's just that I did numerous of time on this. That's the reason why I'm able to set it this way. I know this is very daunting to set one at a time, but to me it's very rewarding when you can push the processor much higher with a lower temperature. Okay, right now this is done. So this is actually done on the curve optimizer, curve shaper, and setting on the PPO limits, right? And I also enable this, the SoC uncall OC mode, which I set this to enable. This is meant for your RAMs, okay, to optimize to the max. Then besides this, right, I will need to set my temperature on my cooler, which I will just set this. CPU fan I know is my radiator fans, and one thing good about ASRock is that you have all this profile, and I'm always comfortable using the performance mode. It doesn't mean that your performance mode that your fan will be very noisy during an idle. No, it's very quiet. Okay, or if you want to, right, you can set it to custom, where you have to go through the temperature and the amount that you want the fan to spin. But for now, simplicity's sake, I'll just set it to performance. And for my CPU fan tool, this is my pump. Okay, I'll set it to this PWM full speed, and that's it. How I conduct the test is pretty straightforward. All these are my system spec. As you have noticed, right, there are no discrete graphic card, as I'll be using the integrated graphic on the processor to stress on the benchmark. And how is it being done? In both ways, I made use of Cinebench R23 together with FurMark. So the FurMark will stress on the integrated graphic, which will push along with the Cinebench on the processor. And these are the stats which are pulled off from hardware info, and you will be able to witness the temperature, the clock speed, and such. And over at this side, right, these are the areas which I will take note to, like the motherboard temperature, the VRM. As mentioned to you, there are no readings on the VRM, but fortunately this board caters with a sensor, so I'm able to sense the VRM. I mean the actual VRM itself, but not the heatsink, right? I'm touching the sensor on the VRM. Then you'll be able to witness the RAM temperature and my M.2, which I mentioned to you. I make use of the default motherboard M.2 heatsink. So I just want to stress how much it can take. Then these are the radiator fans. Now my pump do not have any readings, as this is a old liquid freezer 2360, but I know it's cycling at full speed. Then besides this, right, take note on the Ryzen master. Now as mentioned to you, the first test that I'm going to do is just by default. Meaning say I just enable the expo profile on my King Bang RAM, and that's it. What you witness right now, right, is all the things done by default. As you can see, I've deliberately pulled Ryzen master to show you that the PPT, the TDC, and the EDC, these are based on default. Okay, so as you can see, right, when I run, okay, just to show you. So as you can see, it's picking up temperature and such. Now the first few minutes you won't see anything much, so let me just jump to the last 3 minutes. Okay, probably I would say around here. Yep. So based on the 3 minutes itself, right, looking at the graph on the clock, core clock, by default it's quite stable, though there are still some jagged, and it's hovering around temperature 78.1 degrees Celsius. And the clock speed average, okay, because this clock speed over here, right, is the average of all the 16 cores, so it's around 4.6 and so, and it does have a max boost of 5.7, which is great. Then looking at the drawn of current, which is about 192, 196 around there, and these are the temperature. Okay, let me just take down the readings so that later on I can compare with the other bench, which I've done. CPU hovering at 79.4. Okay, clock speed is around, okay, I would take one of the cores. Max will be, okay, 4.7. 4.7, let's see, 01. Oh, 46 max. Okay, this is megahertz. Then for the motherboard temperature, 46 degrees Celsius. Now, for some reason, right, this board has a very good temperature on the motherboard. And even on the MOSFET, it's actually 48 degrees Celsius. The chipset hovering very well, 55.6. In fact, most of this temperature, right, doesn't reach 50, 56 or 58, not even touching 60 degrees Celsius, which is good. Now, the DDR5 first slot is 45.2, and the next one is at 44.8, and the M.2 is 47 degrees Celsius. Now, as for the score, right, at the end of the time, okay, weakness again, see, this is quite consistent. As in, like, the flatness of the clock, though there are some jaggeds, it's still considered okay. Now I'm just going to pull to see the scores. Okay, this is the score. So it's at 39K 300. Now moving along with the PBO2 and the curve shaper. Okay, this is the one. I'm so sorry that it's slightly smaller because I want to show you what I've done with the CCD0 and CCD1. As you can see here, where earlier on I've not done any setting, but over here I've done, which I've set the PPT to 230 watt, which you can see over here on the Ryzen Master, the TDC to 215. Now for some reason, right, this motherboard does have its limitation. Right after 180 ampere, right, I will not be able to set the amperage that I wanted. For example, right now it's actually 215 ampere, right? You see, it locks to 218. It doesn't go beyond that. So I guess that's the limit of this board. But nevertheless, the rest I can, I can provide the power source for it. For EVC, which is 215 ampere, see, I've set 215 ampere. And the CCD 0 and CCD 1, right, they both have different negative magnitude, which is the first 8 core minus 20, the last 8 core minus 15, as you can see over here. See? And with this run, right, I just run the thing. Okay, probably down here. See, it's running. Looking at the temperature and such for the first few minutes, well, nothing much to see again. So I just pull to the last 3 minutes. Okay, probably I'll say around here. Yep. Now, it did pull up the temperature, no doubt, but take a look at the frequency. See? It's very flat. No jagged, no nothing. This is something which I would like to see when I use the system. It tells me that it's very stable. And having to say this, right, look at the core clock. Averaging is not on a low frequency. In fact, it's on a high frequency. As you can see on Ryzen Master, right, see, peak speed is at 5 gig, no longer at 4 point something, which earlier on when you see the default, right, it's running on 4 point something. And it does boost to max boost, which is 5.7. And looking at the temperature again, it does not, okay, it does not go above 60 degrees Celsius. And some of this, right, they have done a shuffle. Okay, probably I'll just stop here and to take down, no, I'll just continue and take down the readings. For the CPU, it went up as I told you, but not very drastic. See? And it's capable to run at 5 gig plus, I would say 5.0. Okay, let's see. Alright, I'll take the average of 5.065. Okay, megahertz. The motherboard temperature, yep, slightly higher, but still manageable. The thing is that one thing amazed me about this board is that it can really sustain within the temperature range, which is very good. Now the chipset is 55.6, which is the same. DDR5 45.2 is the same. This is slightly higher, 45 degrees. and this is at 45. Okay, and right now pushing towards the result. Okay, just to show you the graph, take a look at the graph. All right, see how flat it is. It is very stable, though there are some dips, but it doesn't matter. It's normal. It is still considered very, very consistent throughout the whole run. Okay, now to the scores, and this is the score. So it's at 42k 3, right? Just do it 42k. Looking at the result is rather impressive, and based on the fact that this board is on a next level whereby I can play much more on the curve optimizer and the curve shaper, bringing up further. As weakness, right, looking at the result on default and after, though the CPU temperature went up a bit, but not really that much. Consider the fact that looking at the clock speed, right, consistently on default is running on 4.7 gig, else after when I took it, right, consistently at 5 gig. That is hell a lot. I mean, to me it's a lot. Reason being, right, when you do your work and such, right, every single megahertz does count in seconds. So imagine that I have a 2-hour project. It's shortened to compile. You know, instead of taking probably I'll say 45 minutes to compile, right, it takes around 30 over minutes to compile. So this saves up a lot of time. And the temperature, look at it. You can compare the default and the after tweak on my settings. It doesn't go a lot, or should I say it doesn't raise a lot. In fact, it's quite consistent. And best part is that this board sustained at this temperature and not going over 60 degrees Celsius. And best part is that looking at the scores after I've done the tweak, see, this is fantastic. In fact, this board is a very matured board that does a next level thing, which is, you know, I've never encountered such board that can do such good curve optimizer and curve shaper. Well done, ASRock. The ASRock B850M Steel Legend Wi-Fi. What are my thoughts? This is a rock solid mid-tier range board. It is as tough as this Arki. Now, Arki is made of plastic, but it's strong plastic. Even, see, this is not hollow. And this board does perform very well. In fact, it's towards another level whereby I can play more on the curve optimizer and the curve shaper. As other boards I've tried, right, be it ATX or m-ATX, I can never exceed the magnitude on the curve shaper to minus 10. No, not at all. Most of the time is minus 5. Now, besides this, right, the whole design, as I mentioned, is very pleasing. I like the fact having the contrast of black and white, or maybe cream white, and with subtle design. Okay, not overdone. And best part, only the chipset area is with ARGB. It's just a touch of ARGB. So as and when, right, for people like me who do not like that, I'll just turn it off. Because if you were to mount this in the case and have just a strip of white LEDs, when it beam onto this board, right, look at how it stands up. I mean, the black contrast, fantastic. And one more thing, alright, it just happened that step on my mind when I was taking close up of the board. It reminds me of a space station, the exterior of it. Alright, so this is actually my thought. Now, it not only performed, that's one thing, the Wi-Fi checked out very well, and best part, the cooling solution is fantastic. Okay, I was thinking that it might not cool that well based on the fact that, you know, there is a missing heatsink over here, but when I touch the VRM over here, right, it's not hot at all. All the heat is over here, which I've shown you. And additional to this thermal sensing, right, be it the CPU and such, right, they give you a sensor cable whereby I can, you know, sense the MOSFET, or should I say the VRM, which shown you is not heating up. Very well done. And also to the fact that the PCIe slot, this metal construction, or should I say the enforcement of the metal that forms the rigidity. Well done. Now there are only two things which I dislike about this board. Starting off with the fan headers. I wish that there's one more fan header over here that says AIO underscore fan, or should I say fan header slash water pump. In the event, right, if you were to plug in a liquid AIO, at least your radiator fan would be over here, which is the CPU fan 1, then followed by the liquid AIO, freeing up the pack over here where you can plug your rear fan. And for the rest, like your front and your bottom fans, right, you can rotate to the bottom, not an issue. So that's the thing that I don't like. Even for air cooler, same thing. And I advise that for air cooler, right, plug it to the rear instead of the top, because the top, which is meant for your top fans, or if you do not want your top fans, you can plug over here. So you'll free up the rear fan header for your rear. For your rear fan. So this is one of it. Second thing is that, okay, the locking mechanism of the PCIe slot is great, but the thing is, in this mid-range, right, at least I would say provide the top M.2 shield with a toolless design so that I can just easily access and such. But it happened that both you have to use screwdriver to unscrew this armor shield. So that's the second point. Now, on top of which, right, speaking about the M.2, okay, as mentioned, there are two things that I don't like, which is the fan header and the M.2 that is not toolless. But there are good things about the M.2. As I show you the solution, right, if you were to plug a too thick kind of heat shield, the M.2 shield, you might have problem plugging in your card. And this is flexible. As I show you that you can switch this whole unit to the top, and this is flat. So this is one good point. Alright, based on the fact that I have nothing much to talk about this, everything checked out well, it's well built, and I believe that it's around 300 to 350 USD. I wouldn't know the MSRP, and it's definitely one of the tough board that I will get. It will be even greater if their Wi-Fi adapter, right, is making use of the Qualcomm, which is 320 MHz. I believe that will pull even higher data transfer, and also providing a 5 gig port instead of a 2.5 gig port. But I guess they need to cut down certain costs so that, you know, it's a budget board, but yet it does perform a solid performer. Alright, now off topic, someone asked me that, hey Cleo, ain't you afraid of using a 9950X or 9950X3D on a ASRock board? I know you guys have been reading a lot about, you know, comments on Reddit and such, worrying about ASRock, that it might damage your processor and such. Well, that is only to a minority, because ASRock has built up its reputation, and a lot of consumers, right, are purchasing their products based on the fact that it's budget friendly and it's of value. So among all those, right, it's only a fraction that's having a problem with the 9800X3D. But throughout my whole run, right, as I always do this, when a sample board comes to me, right, I'll make sure that I'll test it first 3 to 4 weeks before I release. Now I've tested so far 2 ASRock board, the other which is the ATX board, and followed by this, and with similar processor that I test with either the 9950X or the 99X3D for a couple of weeks before I release my content, I have no issues with, you know, running ASRock. Just make sure that you update to the latest firmware. And some of you might, you know, mention that, oh, I can't run this RAM, I can't run that RAM. Well, that's the reason why. Okay, not advertising, but I would be straight out. These are King Bang RAMs. In any situation, okay, besides ASRock, ASUS, MSI, etc. Sorry, ASRock, I got to mention about this. This RAM just plug and play. I don't have to worry about anything. It will just run as is, you know, cache latency and its bus speed without any issues. And I personally love this piece of RAMs without ARGB is just gunmetal. The cache latency is CL28, okay, running at a bus rate of 6000, and these are 32 gig kit. As for this, right, yeah, purposely match with this board as in white theme. They have ARGB, and this is CL32 running at a bus speed of 6400, also 32 gig kit. And for those of you, right, who, I know you are into technology, but if you do not need so much RAM, right, why trouble yourself to run a 64 gig, 96 gig, 48 gig at a tight timing and a high bus speed, which I feel that is redundant. I myself, as a content creator, I do my work on 3D rendering and such, right? 32 gig kit is more than enough for me, alright? It's just a matter of fact, for me, right, a lengthy time. By right, I should be getting a 64 gig, but I choose to run comfortably on 32 gig kit. It's more than sufficient. Alright, so that's my tip for you guys. With this said, I'd like to thank ASRock that provided this solid board. My goodness, this is fantastic to share with all my viewers out there. And for those of you actually new to my channel, welcome to my channel. If you like my content, do remember to subscribe and to hit on the notification bell button. Now, don't go away, as I will introduce you the UEFI fully after this. This is the UEFI interface. When you first boot up, it will take you to the advanced mode. There is a easy mode. Right, some of you might not like it as the color of it, but it does function. Basically, in easy mode, you have all the status over here, what kind of processor you're using, the RAM information on your DIMM slot. You can set the profile, X-Pro or such, so you can click. Then down here are all the storage that you populated on your M.2 or even on your SATA port. Then over here you have the temperature of your CPU and the motherboard, inclusive of the current that is drawing, which is the V-core. Then over here are the status of your fan, and below is the throttle limits that you can set. You can set to this or such. Then here is the time and date, and this is the boot party. And how boot party work is that, assuming you have two OS, the top, which you can see here, Gigabyte, assuming this is Windows 11, and right below this is maybe Linux or such. So if you want to boot to Linux, you can just pull this, hold on it and drag out, and this will boot to Linux. If you want to boot with Windows, you just drag this up. Need to say when you boot up. Alright, so the interface is pretty straightforward, and the polychrome, right, as mentioned to you on the motherboard, there's only the ARGB effect on the chipset, so you can turn it off. Languages, I don't have to say. Then over here, right, sorry, I forgot to mention, if you have done all the settings and you want to reset, you can just reset, load to default, save, and to exit. Then coming to the advanced mode, you can either click on F6 or press on this button over here. So this is the advanced mode. In advanced mode, first thing you'll see under the main category, you will see the BIOS version, the processor that you are using, and what are the RAMs that you are populated. Next will be the OC tweaker. Now for gaming mode and Zen 5 game optimization, I'll leave it as it is, do not touch. In the event, let's say your processor is able to run at 200 watt TDP and you don't want to run that, you want to run it lower. But when you're doing this, right, there will be a drop in performance. But if you choose to do so, you can enable this TDP at 105. Performance boost, I wouldn't use this at all based on the fact that it's based on Cinebench profile. I'll just leave it auto. Performance preset, well, if you do not want to go through the hassle of doing the tweaks on PBO2 and curve optimizer and such, right, this is a one-click solution. You can choose whatever profile you want over here. You want your system to run at 85 degrees Celsius, okay, and not more than that, you can set to this. And if you want some fine tune, right, instead of finding all the points and all the anchor points and such, you can make use of this, which has the temperature inclusive of the curve optimizer, which is -20, -30 or -40. And in the event if you can't run, let's say -40, come back to the UEFI, step down to -30 and such. And all these profiles are done in sequence of temperature, which is 85 degree, 75 degree, 65 degree, and that's it. Pretty straightforward. Now, platform thermal throttle, I would say that by default on this motherboard, right, is 85. You can set it to 95, which I did. By all times, you can set it auto, leave it. CPU overclocking, these are manual. Okay, you can set your CCD and such. Same goes to the integrated graphic overclocking. You can set yourself. Okay, DRAM frequency, normally I will not touch this. I will just straight go to the DRAM profile configuration and to set the expo profile. It's pretty straightforward. Then if you want it more challenging, having this profile run, right, you can fine tune your DRAM timing. So these are the configuration. If you don't want to run it cache latency of 32, you want it tighter, you can set 30, you can set 28, but no guarantee that you will work. Okay, normally when you do that, right, normally when you do a tighter timing, right, you will need a higher voltage. So just leave it as it is. Then all this, don't touch unless you know what you're doing. Providing more voltages, right, will harm your motherboard, so leave it as default. Now, Infinity fabric frequency, on 1:1 ratio, it will be on 2000. You can set based on the calculation. Okay, I'm not going to go in depth on your RAMs, probably a 6400, etc. You can do your calculation over here, which I will not touch. Now, uClock DIF mode, based on the fact that I'm using a 6400 bar speed, I can only trigger at a 1:2 ratio. In fact, best to run your RAMs at 1:1 ratio, which normally at a bar speed of 6400, yes, you can try, but it won't be stable, as what I've encountered. Then the SoC, okay, all these voltages, right, I will not touch at all, except for this, the SoC uncalled OC voltage. In fact, you don't require 1.2, you can press it down to 1.1. If it's not stable, then go back to 1.2. Okay, other than that, don't touch. Next will be the external voltage setting, which I shown you earlier. I can do offset. And one thing good about ASRock, at all times I can just minus 100 millivolt, which is 0.1 volt, as compared to other motherboard, which I can only set 0.05 volt. Okay, for the offset. So I pretty much like this function. And for the load line no load line calibration over here. Okay, now for SoC voltage and such, right, I will not touch. This will I'll just leave it. Next will be the advanced mode. Okay, just to show you CPU configuration, you can set all this if you want to, and at all time leave this as AMD CPU FTPM if you are installing Windows 11. Alright, and some of you might have dual CCD like what I'm having. You can set this to disable, meaning you say you are only concentrating on one core, or maybe a first 8 core and nothing else. This is good for gaming, but I've not set this. I'll just set it to auto, as most of the time I'm actually using work on my PC. PCIe configuration, this is where you set your resizable bar. By default, it will be enabled, so you don't have to do much, but you can counter check. Onboard device configuration. Now, all this you can set. With this, say, right, one thing very good about this motherboard, or in most ASRock motherboard, the ARGB effect on your motherboard, you can come here to turn it off. Right, when you set this off, right, the moment you click it, your ARGB on your motherboard will just turn off. Neat, eh? Then all these are the display priority. You can set it if you got, if you got external graphic card, right, it will just read that. If not, by default, it will just run internal. You can just leave it as it is. Onboard audio and such, the LAN, the RJ45 socket, the Wi-Fi and the Bluetooth, all this I'll just leave it. But for my case, I'm using audio interface. Normally I'll just disable. By disabling things that you do not use, right, you will make your system boot up faster. Okay. Next will be storage configuration. See, these are all the SATA port. Now, in the event if you boot up Windows and you have a SATA hard disk, let's say you want to unplug it while your Windows is on, make sure you come over here and to set this hot plug to enable. So this will allow you to remove your hard disk while the operating system is still running. But of course, on the operating system, you will need to eject off the hard drive. Okay. NVMe configuration, I only have one. In fact, this is just to show you the information. Doesn't really configure. ACPI configuration. Okay, these are the things that you can set. And as usual, PCIe device power on, I will just set it enable so that I can remote with my mobile device to turn on my machine, but make sure that there is a LAN cable connected to your system. Then one of these days I got to show you guys how I did this. It's just that I too packed with work. So sorry about this. USB configuration, these are either you enable or disable. I'll just leave it. Trust computing, all the security stuff, which I will not touch. AMD CVS. Okay, these are things that you can configure, up to you. You have to check enablement, more advanced user, which I will not touch, just to show you what they are over here. Okay, if I'm going too fast, right, you can just pause, alright? Just showing you all the folders, what they have. See, you can go deep into it. Okay, UMC common option, which is all your DDR5 stuff, very into detail. I wouldn't have a clue what these are. Maybe I have time, I read through it. NBIOS, NBO common option. Okay, some of you might want to use this as you wanted to just use the integrated graphic card, right? You can come to the GFX configuration and to set this, either you disable or either you enable. Okay, this is actually for this discrete GPU, alright? Meaning say you are using a discrete graphic card and not the integrated. So you just enable this. So you just bypass the integrated and to make use of your discrete graphic card. But one thing bad about this, if you enable only your discrete graphic card, in the event if it doesn't boot up, right, where you need your integrated to boot up to UEFI, right, you will have to clear CMOS. That's the thing. So I'll just leave it auto. But most of you will just enable your discrete graphic card and to disable the integrated based on the fact that you want more FPS on your gaming, which I can understand. The rest you can just set, up to you. Audio configuration. Okay, this I have no idea what it does. Probably those high, those expert on audio, right, will understand what this is. I will not touch. PCIe loopback, I wouldn't have a clue what this is. Persistent mode legacy, I also do not know what this is. In fact, all this I do not know what they are. So I just leave it. SH common option, USB. Oh, okay. Probably controlling your USB ports and such, which again I don't go into detail. Now SMU common option. Now this you can set the TDP, EDC and such is a subcategory of what you want to configure on your system. But if you want to use PBO tool, right, I wouldn't advise you to touch anything down here. Leave it as it is. Then SOC miscellaneous control. Alright, these are the things that you can set. Followed by the PROM21 chipset common option. Wow, a lot which I have no idea what these are. Again, I'll just leave it as it is, not going to go into details. Whoa. Okay. PCIe power management features. Again, I wouldn't know what this is. I'll just leave it. So these are the things on CBS. Now on PBS, again, all this stuff, it will show you the configuration. You can just configure, up to you, right? Just to show you. Alright, this is the thing that which I will do. AMD overclocking. Okay, click on accept. This is where you can set all the stuff like your RAMs, your RAMs, your manual overclocking and such. But I only often use things like this, the uncalled OC mode, which I'll trigger enable. This is to optimize my RAMs. And another thing which I will do is the precision boost overdrive. Okay, and I did show you how I did, so I don't think I am going to go throughout. So this is actually the BBO2. If you missed it, you can rewind and go to my configuration on how I do all my configurations. Alright, so this is overclocking. Now coming to this, right, as you can see, the BIOS setup text color default, these are all in black. If you want to change color, right, you can change your color if you want to, but you need to save it, reboot it. Then let's say you set this to yellow, right, all this wording will turn into yellow. Okay, and I don't think white background suit any of these colors over here except black, so just leave it as it is. Now if your mouse is laggy during the UEFI toggling, right, you can set the speed. Okay, there are ×2 ×4 to speed up the process of your drift and clicking and such. Active page entry. Now when you boot up the UEFI, the first thing you will take you to the main page, which is this. Okay, if you want to change it to boot up and to show you OC twinkle, just set this active page on entry to OC twinkle. Okay, this is what it meant. Now for full HD UEFI BIOS, this is, I let it be based on the fact the system will detect what is best resolution for your monitor to project the UEFI interface. Now the style, as mentioned to you when you boot up, this is the advanced mode. If you want the simple mode every time when you boot up to UEFI, right, you can just set to easy mode. Okay, tools. Now ASRock has always got this function which I really like a lot. That is, if you have any ARGB strips or additional ARGB devices connected to the board itself, right, you can come over here to set. For example, you want to set to breathing, strobe, cycle, etc. All this effect, you can do it over here. And do take note that when you're doing static, right, you will need to know the RGB numbers, as in like the red, green and blue. You gotta key in the figures, normally up to 258 colors. So sorry, 255. So you got to do all the combination down here in order to get the color that you wanted. Brightness, well, you can tune it down. 105 is half, I should say is okay, or you can tune it lower. Anything that's lower 50, right, you can't see the ARGB, so take note of this. Alright, once you have done, right, you can just apply to all channel and you can save the profile if you want to. Next will be the SSD secure erase tool. You can make use of this to secure erase your M.2, but I advise you not to. Reason being, right, I think I mentioned this again and again. It's like in the past when I did this on my M.2, my M.2 not able to install any application, or should I say install the OS. So I will make use of the M.2 own application, okay, through Windows to do the secure erase, and not through the motherboard, which is down here. But you can do the media sanitization as in like just a brief format. You can do that, which is this function over here, this one. Right, you can select the drive and just sanitize. In fact, it will tell you this. See what it does. Instant flash. This is meant for you to do the BIOS flash in UEFI mode. Instead of choosing the BIOS flash pack, which you have a button behind your motherboard, auto driver installer, leave this enabled. So the very first time when you install Windows, right, when you boot up to Windows, right, it will prompt you to install the necessary drivers like your chipset drivers, your your Wi-Fi drivers, your LAN drivers and such. So this is very useful. Instead of going to the official website to download the drivers and to install it individually, right, this does everything in one package. Hardware monitor, as I show you, these are to toggle your fans and your pump. So you can switch, for example, okay, earlier on I set this to water pump. I know that CPU fan 2, I've connected to my water pump to it. That's why I can switch. In fact, this is just an indication telling you that, okay, right at the top, right, when you see over here, water pump, it will tell you what that is. And as mentioned, right, all the fan headers except for CPU fan 1, this is 1 ampere. The rest are all 2 ampere. So we can set either DC mode or PWM mode. Normally we will do PWM mode, then followed by the speed of the pump. Okay, probably I'll set this back to performance. Okay, so we can set all this. And if you fancy, right, you do not want to follow, for example, let's say chassis fan 1, which is your case fan, you set this to PWM mode and you run by performance and you don't like the profile, you can set it to custom, where you can do point to point according to the temperature and how much percent you want your fan to run. Okay, there are certain fan temperature over here, as you can see, temperature 1, temperature 2. The higher numbers you go, right, like temperature 1 to 2 to 3 and to 4, right, in fact is the degree of your CPU. Okay, you can set that, and the fan duty of temperature 1 and such is going accordingly to that temperature, and you set how strong you want the fan to spin. Other than that, oh, forget to mention, besides this, right, okay, let me just set to performance. Next is what are you going to monitor, as in how your fan is going to react. So normally I'll just put it to motherboard, monitor CPU instead of the motherboard, because your CPU will raise up temperature higher as compared to your motherboard, so you want to set it to monitor CPU. Alright, now fantastic, this is auto tuning. Then you say, okay, not auto tuning, you can use a graph to do your tuning. Alright, but you need to set like custom, then you show you the point, then you can just pull and drag and such. Okay, these are those who are familiar with motherboard like Gigabyte or Asus. Yep, they will use the graph. Personally, I do not like graph. I like to manually set it. Okay, let me just exit this. Fan tuning, you allow your system, or should I say the motherboard, to detect the amount of air in to the amount of air out. This is useful only for case fans. So if you want to choose this, right, by all means go ahead. You can just fine tune it. Okay, it will take a few cycles to detect what are the areas that need to cool down, but I don't really use this much. Security, in the event if you have set all the configuration and you share your PC with your siblings, you don't want them to touch your UEFI, you can set a supervision password, which is yourself. And if you want your siblings to touch but with their own settings, you can set a user password, which is another account for them to log in. So whatever configuration they have done in this user password, right, is based on their configuration. It will not touch on your configuration. Secure boot, this is mainly for people who want to play games, which is Valorant. ASRock, thank you very much. By default, you have set to custom. Well done. And for some reason, right, I mentioned many times on motherboard, if you want to, probably you have done with Valorian and you want to rebuild your OS or do a fresh installation on Windows 11, you will need to come over here to set to standard. Else for ASRock, you don't have to. It's actually auto switching, which this is what I like. Key management and this, I wouldn't have a clue what these are for. Probably these are the advanced secure kind of thing, like the BitLocker and such. Image exclude policy. Again, I wouldn't know what this is. So this is security. Now for the boot, as mentioned to you, okay, you can select what to boot first. Assuming this is Linux, right now it's actually Linux. You want to boot your boot priority as Windows, right? You can just switch. Okay. CSM for legacy, normally I'll just disable. The rest I won't touch. Same goes to this, I will not touch. Now, please be careful with the fast boot, right? A lot assuming that when you disable this and such, right, you will not cause any problem. It does cause problem for me. Okay, so try to leave it as it is, don't touch. Last but not least, the exit. These are all self-explained. I don't have to mention about it.